Alright, in our story problem, we have Dorothy has $30 to spend on holiday cards. Large cards cost $2.50 each, and small cards cost $1.50 each. And they want us to write and graph an inequality for the number of cards Dorothy can purchase. Well, we know Dorothy has a budget. She has a maximum of $30 that she can spend on holiday cards. So we know that anything that she spends, Dorothy's expenditures on cards has to be less than or equal to $30. Okay? So there are two types of cards. We have large cards. So we'll call the number of large cards X. X equals number of large cards. And we're going to let Y equal number of small cards. Okay? So we know that the money she spends on large cards plus the money she spends on small cards has to be less than or equal to $30. Okay? Well, how do we express the amount of money she spends on large cards? Each large card is $2.50. So we know $2.50 is going to be in there someplace. Now, if you stop and think about it, if I says, gee, I want to buy 2 cards, now you would probably add $2.50 and $2.50 together. Another way to look at it is you would multiply $2.50 by 2, which is, by the way, the number of large cards. If I asked you how much, if she bought 4 cards, how much would it cost, you'd probably go, I'm hoping you would go 4 times $2.50, which would give you 10. So in other words, to find out the amount of money that she spends on large cards, we would take the price per card times the number of large cards, which in this case is represented by the variable X. So 250X. Using that same line of logic, we would say that the amount spent on small cards could be written as $1.50 times Y. And again, the sum or the addition of these two amounts have to be less than or equal to 30. So there it is. We have 2.5x plus 1.5y less than or equal to 30. Okay? So let's use x and y intercepts in order to graph our line. All right? So if I have y-intercept, so in other words, I'm looking for the point on the y-axis, which is the small card axis, y-intercept. We're going to let the variable x equal 0. So we're going to take this inequality, 2.5x. Actually, we're going to look at this like an equation right now. So 2.5x plus 1.5y equals 30. If I substitute 0 in for x here, 2.5 times 0 plus 1.5y equals 30. This term drops out and I'm left with 1.5y equals 30. If I divide both sides by 1.5, we wind up with y being equal to 20. So my y-intercept is going to be the coordinate 0, 20. So I would find that point on my y-axis and I would color that in, fill that in. Now doing the same process with the x-intercept, So using the x-intercept, so that is a point along the x-axis, so I know my y-coordinate is going to be 0. So I'm going to let y equal 0. Again, take the same relationship, 2.5x plus 1.5y equals 30. This time I'm substituting 0 in for y, so I have 2.5x plus 1.5 times 0 equals 30. This term drops out, so I'm left with 2.5x equals 30. Dividing both sides of this relationship by 2.5, we wind up with x being equal to, let's see, 30 divided by 2.5. Gee, if I forget that, that's really something, isn't it? So we can certainly find that out though real quick. There's nothing wrong with grabbing a calculator if your mind is addled, which mine appears to be at this point in time. Debug and go. So I would simply go 30 divided by 2.5, and I get 12. I knew that. So I have 12. Okay, so this coordinate then is going to be 12, comma 0. So I find that on my x-axis, and now I'm simply going to draw a line. Draw a line from this point down to this point. Alright? So finally, the last thing we need to do is do a test point. So again, a good test point is 0, 0. So if I take the inequality, 2.5x plus 1.5y less than or equal to 30, and I take and substitute the values of 0 in for both x and y, we see that the whole left side goes to 30, and you say, gee, is that true or false? Well, 0 is less than or equal to 30. That's a true statement. So we are going to shade on the 0 side of the line. And that is the correct graphing.